welcome student to question number C, where we need again to find the increasing, decreasing intervals, local maximum and minimum. Moreover, we need also to sketch the graph of this function. So as we did before, step number 1, we need to find the critical numbers. The critical numbers are the numbers which are nominated to be local maximum and local minimum. In order to find the critical numbers, we need the derivative. So we get 3x squared negative 12. And then we ask ourselves, does this derivative at any point does not exist? Do we have any point where we have a problem with this function? The answer is this is not happening. Why? Because there is no denominator, no problems with this function. And that's why we will not explore this case. The other case for the critical number is equal to 0, which means 3x squared negative 12 equal to 0. That means x is either negative 2 or x equal to 2. So those are the only two numbers that could be local maximum, that could be local minimum. It could be, of course, neither, but those are the candidates that we have. Step number 2, we will take this derivative and we will see where this derivative is positive and where it will be negative. So step number 2, find the interval where f of x is increasing / decreasing. So here we put the function. Next step, we need to write the number line. So this is the number line. And now we need to find the sign of the derivative. In this number line, I have -2, and here I have 2. Now, how do I know if this area is positive or it is negative? Choose a number, test point here between them. So I will choose 0 and substitute 0 here. This area will be negative as a whole. Now, go to this area, choose a point. I will choose 3. Substitute it here, you will get positive, so everything in this area will get also positive. Similar thing for this area, if we choose a test point and we substitute it, it will always be positive. So we have increasing, we have decreasing, and finally we'll have increasing. So we have increasing in the first part, decreasing in the second part, and finally, we have increasing in the third part. So if we write it as interval, so increasing and decreasing, because the question is we need to write it down as an interval. So decreasing, it's clear it will be from -2 to 2. Increasing, you start from -infinity to -2, and then you continue from 2 to infinity. How do you join those two pieces? We write the union sign. And that's what we found here for the derivative. Next and final step is to find where it is local maximum and local minimum. So step number 3. Find local maximum / local minimum. I will paste the same table we just did because it will help me directly finding that the maximum is happen when you have increasing and then decreasing. Go up and then go down. So this will be local maximum. And for local maximum, we can have just take this one here. So just let me write it from scratch. Local maximum is at x equal to -2, which is, we call it maximizer because it causes the maximum, and the local maximum value. Remember, the word maximum, I'm talking about the y. So the local maximum value is y equal f of -2. How do we find f of -2? We go back to the original question, substitute -2, -2. The answer will be just 19. Next, we need to find local minimum is at x equal to 2, which we call it minimizer. And the local minimum is, or the local minimum value is y equal f of 2. And that, it means we go here and we substitute 2, 2. It will be -13. If you have the calculator, the answer is -13. That's how we find the local maximum, local minimum, and we write their values. Now, in this question, I've been asked one more step, which is we need to sketch the graph. So let's use all this information, sketch the graph, to sketch the graph of this function. So in order to sketch the graph, you need to have x-axis, y-axis. First of all, I have two important points, which is 1, 2, 1, -2. I know what happened is at -2. At -2, we have a local maximum. So I will go at 19, and here I have a local maximum. So the function should look like this. How do I know it looks like this at this point? Because this is local maximum. And then at -13 and 2, the function has local minimum. So I should be joining this, and then this, and then this. So it will look like this shape. However, just let's, for now, be a bit accurate. Let's find where the function will intercept with the y-axis, the y-intercept. And remember, in order to find y-intercept, we need to plug in 0 here and 0 here, so we get it at 0, 3. So we need 1, 2, 3, this point. And now all what you need to do is just join them. If you join them, this and this. So this is a small sketch, or at least it gives me the general shape of the function. If I try to sketch it, this is what we will get. This is the function, how it looks like. Using the local maximum and local minimum helps me a lot in trying to sketch the function. Next question, part D. Again, we need to find the local minimum, local maximum, the interval of increasing, decreasing. So the first step, we will find the critical numbers. Let's see how we find the critical numbers. We find the derivative, and the derivative will be 3x squared minus 12x plus 9. And here we have two options only. Either the derivative does not exist, which will not happening. And the reason why this is not happening, because I don't have any problem with this function. If there is no denominator, I'm good. I have to move around. Now, if the derivative is equal to 0, it means I need to write the derivative, make it equal to 0, solve it by quadratic equation, by factoring. If you do everything correctly, x would be equal to 1 and x would be equal to 3. So you have only two critical numbers. Maybe one of them is local maximum and one of them will be maybe local minimum. So we find the critical numbers, we go directly to step number 2. In step number 2, we need to find the interval where f of x is increasing / decreasing. Now, how do I know where it's increasing or decreasing? Where the derivative is positive or the derivative is negative. We need to know this information. So first of all, let me just write the derivative again because I will use it. It was 3x squared minus 12x plus 9. In the next step, we'll do the number line. And in the number line, you have to tell me what is the sign of f prime of x. What is the sign? Is 1, 3. Now, what is the sign of f prime? If we substitute 1, and here we substitute 1, so we get a negative. So in the middle, it will be just minus, minus, minus. If we substitute a number greater than 3 in the derivative will be positive. Less than 1, for example, try 0, it will be positive. So you have increasing, decreasing, increasing. So we have increasing in the first part. We have decreasing in the second part. And finally, we have increasing in the third part. So if we write it as our summary where the function is increasing, well, increasing, we start from minus infinity to 1, and then we continue from 3 to infinity. We join it with a union, and then we have it decreasing, which is from 1, we go directly to only 3. And that's step number 2. Step number 3, we need to find the local maximum and local minimum. Is the 3 local maximum or local minimum? Find the local maximum / minimum. Now, how do we find the local maximum minimum? We look at 1. Is it maximum or minimum? That's the big question for today. Well, because it's increasing and then decreasing, it is like maximum. This one decreasing and then increasing, this is minimum. So, local maximum is at x equal to 1. This is, we call it maximizer. And the local maximum value is y equal f of 1. We just substitute 1, 1, 1. If we substitute 1, 1, 1, the answer will be 5. So this function, the maximum locally will go 5 and then it will go down, and local minimum is at x equal 3, and this will be minimizer. And the local minimum value is y equal f of 3, and we go to the original function and substitute 3. And that will be whatever we get after we substitute 3, that's what we will get as local minimum, and the answer is 1. And that's how we do the 3 steps to solve this question. Now, there is one example we have seen before, which is example B, and something happened in example B. Let me just go back to example B, and in particular, this graph here. In this graph, you can see at 0, it is not max and it is not min. It doesn't go up and down or down and then up. So this has a special name where we don't have maximum or minimum, and this special name is what will come next. It is known by horizontal point of inflection, HPI. So a point, we call it HPI if the sign of the derivative after we do the number line does not change around the critical number. Now, let's do it in this example and see if we find a horizontal point of inflection. So find relative extremas and the horizontal point of inflection. So again, we need to find the derivative and make the derivative equal to 0. Next, we need to make the derivative equal to 0. So we take x cubed this is equal to 0. And now what we need to do is we need to take x squared, and here we write x minus 2 minus 4x minus 2. I will take common factor. Now take x minus 2 as whole common factor. What is left is x squared minus 4 equal to 0, which means either x equal to 2 or x equal negative 2. And now what we do next is we need to write the number line. So you have minus 2 and you have 2. And you need to find what is the sign of f prime of x. And the sign of f prime of x will be just x cubed minus 2 minus 4 plus 8, sorry. And now we just have to pick points and check. First of all, if you take 0, 0, 0, 0, it will be just positive here. Now take a point less than minus 2. So I will choose minus 3. So you substitute minus 3, minus 3, minus 3. It will be negative here. So what we have decreasing, we have increasing. So here we have local minimum. And now if we choose a number greater than 2, for example 3, and substitute it, the answer will continue to be positive. So what do we have here? Here we have horizontal point of inflection at 2. So horizontal point of inflection is at x equal to 2. And as a point, it will be 2, comma, and we substitute in the original function 2 here, 2 here, 2 here, 2 here, and we get the answer.